You know, being the lovely sister that I am, my brother actually didn't come out today, so now I get to have the whole weekend to tease him about not making it to my talk this morning. I'm just going to open my presentation here. Okay, there we go. You know, people always used to ask me where I picture myself 5 or 10 years from now, and I never really know the answer because there's so many things that I want to do. I want to be traveling around the world, hiking, backpacking, maybe on a mission to Mars, who knows. But I never imagined that I'd be back here today speaking to all of you in the city that I love, so thank you very much for having me. Going through school in an engineering degree, I'm sure many of you know, you don't really have much time to read for leisure. You're so busy going through all your classes, trying to finish all your labs, do all your homework, do all your assignments, and on top of that, the last thing you want to be doing is reading. You probably want to be doing other extracurricular activities. Now people joke that when I am reading and when I'm looking for a book, I can always be found in the what every man should have or the it's a guy thing section of the bookstore, which I think are all named, because that's where I can find the mountaineering expeditions, stories about them. That's where I can find stories of space travel or memoirs of the Apollo era. And one of my favorites has to be Failure is Not an Option by Gene Kranz. It's the stories of flight director Gene Kranz during the 60s, the Mercury and the Apollo era, when they were trying to land people on the moon. And usually when I get a book, I like to flip through it and get a feel for what it is. Sometimes it has inserts with all the pictures in it, so you flip through those. And I flipped to the back, and on this one single page, there was something called the Foundations of Mission Control. And it was a simple list that Gene Kranz developed for his team to ensure that people landed safely on the moon. Simple rules to make sure that his team excelled in professional excellence. Rules of teamwork, competence, discipline, responsibility, and confidence. And these fundamentals were so important when they were innovating in such an extreme environment to make sure that they accomplished the goal of landing people on the moon. And throughout the projects I've done, I've come to realize how important each of these foundations really is. So when I was doing my degree here in Calgary, I had this dream of going to space, but decided to stay here. There really isn't much in the way of aerospace engineering or space projects. So when I was presented with the opportunity to work on a solar-powered car and design the aerodynamic shell, which you can see on the screen here, I jumped at the opportunity. And for the 2.5 years that I worked on this project, I learned the ins and outs of teamwork, the camaraderie and support that can be developed when you're working together with a group of people to accomplish something amazing, but then also the frustration that can arise if people are overworked or if success isn't immediate. But the success of that solar-powered car and the legacy we started wouldn't have happened if we didn't work together and cooperate as a team. And we certainly wouldn't have been able to race across North America if we weren't working together. I think this is a cool picture. We were at the Texas World Speedway getting ready to prepare for the race because the car has to qualify before it can actually be put on the highway. So I also realized when I was working on this project how important it is to appreciate your opportunities. The few of us that actually worked very hard to build that car and put it together in 9 months, and there were many guys on the project who put in more hours than I did. And then the few of us that actually got to race across North America, crossing the border into Canada, and then finishing in Calgary here with 10,000 people cheering you on. You know, I'm just noticing that I think my dad is actually in this picture. That's cool. It's an amazing and unbelievable experience, and you really have to appreciate and cherish those moments. So this was about respecting and utilizing the abilities of others, realizing that we all work towards a common goal, and it depended on the success and efforts of everybody. So the only logical thing to do after you've driven a car across North America is learn how to fly a plane. So I used the opportunity during my internship at Devon, Canada, with free evenings and weekends, and also a salary, to get a private pilot's license. So I don't know if anyone in here is a pilot or has flown in a small plane, but it really is quite a surreal experience. It can be so quiet, just listening to the engine rumbling or talking on the radio communications, but it's also really thrilling at the same time, and it requires so much focus and attention to detail. It's about preparation and dedication and execution. And that's when I learned real hard and real fast about competence in the systems that you're using. Whether it's preparing for your flight, picking the route you're going to take, selecting your waypoints, or calculating the weight and mass balance from your plane. It requires you to be in complete control and always knowing what you're going to be doing. When you're learning to fly a plane, you fly out in a designated practice area. I don't know if anyone going out on the Trans-Canada sees that Petro-Canada on the right side of the highway just outside of the city. But that's one of your waypoints for getting to this practice area over the foothills. And you basically learn techniques for flying a plane and then also recovery procedures in case something goes wrong. And one of my favorite things to do was spins and spiral diving and learning how to recover from them. So you're spinning really fast towards the ground, and then you have to be able to get out of that situation. You can see the look on my mom's face now. But my flight instructor, Athenia Jansen, loved to let me just do them over and over again. And aside from the adrenaline of it and having a lot of fun with it, it really is a serious situation that you can get yourself into easily, and that you need to be able to get out of and understand the system that you're using and its complexity. So situations like these require total preparation and complete dedication, for they don't tolerate the careless or indifferent. And that goes for so many other situations in life. My parents, whether they know it or not, brought me up believing that if you work hard, help others whenever you can, and have fun along the way, everything else just falls into place. And I kind of lucked out with that. 2 years in a row getting to intern at NASA Goddard Space Flight Center and NASA Ames Research Center, working on a mission to Mars in the latter case. And that's when I really learned the importance of having discipline when you're working on a major project, especially projects which are risky business ventures or trying to accomplish something that no one has done yet. For example, planetary resources goal to mine an asteroid, or MDA space missions, satellite servicing infrastructure, or in this case, a mission to Mars. So in a typical Martian mission, if you're following the news about Mars One or Inspiration Mars, they're going to be sending crew members to the planet, whether it's a one-way trip or not, and then they set up a habitat on the surface of the planet, set up a sustaining life support system, do all their experiments on the surface. But the project I was working on was innovative in that we were hoping we'd be able to send a crew to Mars that could live underneath the surface in a network of really complex lava tubes, or a cave system. And we were hoping that by having people live under the surface, it would protect them from things like violent dust storms, or solar winds, or galactic cosmic rays and solar proton events, which sound like things from a science fiction movie, but they're a real problem for people traveling on a Mars mission, and something that you'd have to be able to accommodate and deal with. So working on this project, I was with about 50 other people that were my age, my peers. They were really dynamic and outgoing and felt like they could change the world, like we could change the world in the face of space. And it became so clear to me in this moment that I wanted to live a life full of peak moments. And when I say a peak moment, I mean when you're completely fulfilled, when you're challenged, and when you're always learning. I like telling this story because I think it's a really good example, but when I was at NASA Ames, half of the campus is the actual research center, and then half of the campus is an old military base, which they set up with some dorms and some other facilities. I think Carnegie Mellon has a building there. And I could walk 100 feet outside of my dorm room and see this McDonald's, the skull and crossbones in the window in front of the iconic Ames hangar. And one day I just wandered inside, and there I found hundreds upon hundreds of film reels with footage from the moon just sitting in the kitchen of this old McDonald's. Footage that no one has seen yet because it had never been processed. I was literally looking at these tiny film strips. And then I could walk 500 feet in the other direction from my dorm room, and there's the high bay for the vertical flight simulator that the astronauts use, or there's the world's biggest wind tunnel. But it didn't hit me how amazing this experience was until I was 18,000 feet in the air with a parachute strapped to my back, getting ready to hurl myself out of an airplane, which in itself was pretty cool. But before I jumped, I looked back behind me, and there was Korea's first astronaut, Soo Yi, with the biggest grin on her face, giving me a thumbs up before I jumped out of the plane. And that's her jumping on the left there. So how often do you get to say you're working at NASA on a mission to Mars and jumping out of planes with astronauts? So for me, that was a peak moment, and we should be constantly striving to get back to moments like those, learning from our past experiences to feed forward into future growth, identifying resources we need to achieve our goals, and seizing opportunities when they're presented to us. When you're working on a Mars mission like this, or the one that I just talked about, with such a large group of people, it really takes a lot of discipline to be able to know when you need to step up and be a leader, and then also know when to sit back and be a listener, and just work together to complete a really complex project. And it also is pretty evident that for a Mars mission, it requires so much expertise, and not just the technical and scientific expertise, but there's also huge social and political implications of sending people to Mars. You wouldn't be able to send a human mission to Mars without doing some sort of robotic exploration first, because then you'd be violating United Nations treaties and laws with protective policies to keep people from cross-contaminating the planet. So you don't want to send humans to Mars with the potential of exploring these latitudes that could harbor signs of life and either contaminate pristine conditions on a different planet, or also bring that contamination back to Earth. So you'd have to do some sort of planetary exploration, like with the rovers that are sent, or you could send some sort of robotic arm with cameras on it to do inspections of these underground latitudes. So I kind of lucked out after that, landing my job at NDA, where I was working with the legacy of Canadian space robotics, so the Canadarms. And there's no better place to learn about responsibility than your first full-time job. So I was hired into a program called the Next Generation Canadarm, and it's basically a stimulus program from the government to look into on-orbit satellite servicing. So all around us now, there's satellites orbiting, and there's also ones that have broken down. So they've either run out of fuel or they have broken components. And if they're not used anymore, they're either left up there to become space junk or space debris, or they're put into a graveyard orbit. So the goal is to be more conscious of what we're launching into space and to take care of those assets by putting either new fuel into them so they can be reused again, or fixing broken down components. So this program designed an entire reference mission from the launch to rendezvous and docking to the servicing tasks that a robotic arm would have to do to pump fuel into a broken down satellite, or to fix or replace electronics on the satellite. And I was hired in as the only operations engineer on the project. So I was basically looking at what the robot could do, where it needed to move to accomplish all of its missions, looking at the camera views that an operator on the ground would need to operate a robotic arm in space. And it was very clear that I needed to take responsibility for not only my work, but making sure that interacting with the mechanical engineers and the designers or the electrical engineers, that all of our work was coming together to achieve something with a purpose and something great. So in the end, everything that we worked towards was to do a final demonstration towards NASA and the Canadian Space Agency, using these ground test beds that we developed and operating them right from our clean room at MDA. So we were doing things like cutting little lock wires on fill drain valves and removing thermal blankets from the valves. So imagine you're all sitting in a room by yourself. You have a GoPro camera on and you have a blindfold on, and you're looking at a tiny piece of floss that's strung up between two posts. And you have a little of the tiny scissors that you use for like manicuring or something. And there's someone in the room next to you who's looking at a laptop like the one I'm looking at with a feed from your GoPro camera. And they're trying to tell you with your blindfold on how to cut that floss. How many of you think you could do it? So that's what it's like to cut this tiny piece of lock wire that you see on the top two pictures. So you have some person sitting on Earth looking at a user interface like this laptop with camera feeds from the tools, trying to tell a robot what to do in outer space to cut this really tiny piece of lock wire. So that's a pretty incredible task and a really risky task that companies are trying to be innovative to do so that we can be more conscious of what we're doing with things that we're putting into outer space. So it was about realizing that suddenly and unexpectedly we could be found in roles that have ultimate consequences, and being able to take responsibility for our actions. If we make a mistake, being able to realize that it's about the project and the greater good, not an individual, and that's the foundation of responsibility. So doing this presentation, I got to thinking whether we're responsible just as individuals for our day-to-day work, or whether we're responsible as a greater community or as a company to make sure that we're industry leaders, to make sure that we, on a world stage, are the best at what we do. So for example, in the aerospace industry, does MDA have a responsibility to make sure that we stay leaders in orbital robotics and space robotics and pushing the limits of what we can do in exploration. So just a little bit of a play-by-play of the aerospace industry in the last year and a half. MDA started off 2012 with a $200 million deal with Intelsat for the satellite servicing program that I just discussed. But it expired because other US companies have started investigating this, and it's easier in the aerospace and defense industry to work as a US company with another US company than with a Canadian company. There were 2 Canadian-funded rovers that ran out of funding. They were delivered to CSA, but it's unlikely that they will ever be flown on a mission. There was an independent aerospace review conducted last year, which recommended that the Canadian Space Agency be removed from any policy-making role regarding space, and that even though the global aerospace economy is growing by 40%, Canada's aerospace economy is actually slowing down. MDA bought Loral Space Systems in Palo Alto, California, which is one of the biggest satellite manufacturers in the world. But whether that will have any impact on the Canadian sector, I think everybody's still waiting to find out. And then lastly, everybody's been following Chris Hadfield's mission on the International Space Station over the last 5 months, and he's done such an amazing job getting people excited about space again and getting people interested in the experiments and science they're doing on the International Space Station. But is that all for nothing? Because they're not launching another human in space from the Canadian side until at least 2016. That's a long time to be waiting to get Canada's astronauts into space again. So sometimes I think Canada is not always willing to undertake the risks associated with space exploration or exploration in general. But exploration is all about risk, and that's how you can aggressively push to figure out why things work and how things work, and that ultimately leads to innovation. And innovation is about a progression of technology, using the lessons we've learned from past experience and past projects to feed forward into future growth. Specifically for the space industry, taking the lessons learned from the shuttle program or from the International Space Station and applying it to this new wave of technology that can help complex projects on Earth be sustainable in an era of extreme change. So through all of these projects that I've worked on, I realized as a woman, as an engineer, the importance of confidence, being able to believe in myself as well as others, mastering hesitation and self-doubt to succeed. Usually when I'm at work, I'm one of the ones who's operating this robot, but I'll be the only woman in the clean room with a room full of male engineers, or the only woman in the boardroom. And I think everybody knows that's the way it is in engineering. We heard some facts before about how many women there are, and those were the facts that I knew 8 years ago when I did my degree. We're really good at resuscitating those numbers over and over again, but what we're not good at is improving those numbers and encouraging more women to get into engineering, because if we were good at it, those numbers would be better by now. I think what we really need to be doing is getting more women into the forefront of the media and showcasing women in technology and engineering careers like so many of you here and myself, and why we love technology and why we love what we do, and having you at the forefront where young women and the next generation of youth can see us interacting with the technology we use. That's how we're going to inspire the next generation of women. We live in an era where you can revolutionize the world with a click of a mouse, and you can spread an idea instantaneously as if it was contagious using social media, using your phones, using the internet. And yet somehow we haven't tapped into that resource to start connecting with the next generation of women and really inspiring them to want to be innovative and change the world. I gave a TED Talk last year, and I did a little experiment with the audience where I had everybody stand, and I said some names, and if they knew the name I said, they were to stay standing, and if they didn't know the name I said, they were to sit down. So not surprisingly, everybody in the audience knew the Kim Kardashians and the Heidi Klums of the world. The next one I did was Marissa Mayer, who's the CEO of Yahoo, and I had over half of the audience sitting, which I thought was surprising because she had just been all over the news for becoming the CEO of Yahoo and the youngest person on the Fortune 500. And then I named some women like Melissa Pemberton, who's an aerobatic pilot in her 20s with over 10,000 hours of flying experience, Lena Gade, who's a race engineer for Audi, who won the first Le Mans 24 hours, and no one in the audience knew who they were. Just out of curiosity, do any of you know who they are? No, that's what I thought. So I think it's strange that we live in a world where we know who the reality TV stars are, but we don't know who the women who are doing amazing things, who are changing the world, who they are. They should be at the forefront of the media, and they should be the ones connecting with the next generation of women. So we need to do a better job inspiring youth and inspiring the women to be curious, to be innovative, to want to change the world, to be responsible for their actions, to understand how to work as a team, to be disciplined, to be competent, to be confident, to be leaders. So now when people ask me where I see myself in 5 to 10 years, I'm still not going to have a clue. I'm going to be wanting to hike mountains, working on projects, maybe doing a Dakar rally. But what I do know is that I want to have better odds of turning on the TV and seeing a space explorer, adventurer, or a scientist than of seeing a reality TV star. That's the future I envision and the future that I hope everyone will join me in creating.